Okay, let's jump right in. Today, we're talking about something pretty amazing, a new way to actually hear the future. Imagine an AI that can listen to the quietest whispers of a machine right before it breaks down, predicting a disaster long before it ever happens. We're going to explore exactly how this incredible tech works. So, to get started, let's think big picture for a second. What is it that really powers almost everything around us? From the huge wind turbines powering our cities to all the industrial machines that build our world, what's the one piece of tech that makes it all go? You got it. It's the electric motor. They are literally the invisible engines of our entire civilization. They're in just about everything, quietly turning energy into motion. You could say that their reliability is pretty much the foundation of our modern lives. But like any hero, these critical machines have a weakness, an Achilles heel. There's a single, super common point of failure that can bring an entire system to a grinding halt, and that costs a fortune in downtime and repairs. Any guesses what it might be?
It's the humble bearing. I know, right? These small, pretty simple-looking parts are absolutely essential for everything to run smoothly. But they're also the most vulnerable part, and when they go bad, they can cripple a motor and just destroy its lifespan.
So how have we traditionally tried to predict these failures? Well, for decades, the industry has been using a sort of diagnostic toolkit that's, let's just say it's incredibly complex. Not to mention, it's way too expensive to use everywhere. Yeah, just listen to industry expert Dr. Howard Penrose. He explains that the old way is all about listening for super specific vibrations. See, when a bearing starts to fail, tiny bits of metal break off, and that creates these high-frequency sounds that you can't really hear. You need specialized, expensive equipment and a very highly trained expert to make sense of it all. And this is where it gets really complicated. To find a fault, technicians have to hunt for specific frequencies, with names like ball pass frequency of the outer race. Seriously. As you can see here, every single type of fault has its own unique, complex math formula based on the motor's speed. This isn't just listening, it's more like advanced acoustic forensics. So this brings us to the real heart of the problem with the old way. It all boils down to two really expensive things. You need high-cost sensors to even capture the sound, and then you need to process massive amounts of high-resolution data. This has just made it impractical for most industries to monitor all their machines all the time. But what if we could get the same results, or maybe even better results, with less? Well, that's exactly where the breakthrough from today's source paper comes in. It's offering a completely new and much, much smarter approach. And this slide just lays it out perfectly. It's a total paradigm shift. Look at this. We're going from expensive, specialized sensors to cheap, low-cost Internet of Things, or IoT, sensors. We're going from needing massive amounts of high-resolution data to getting fantastic results from low-resolution data. And we're ditching the complicated manual math for a smart, hybrid AI. The tech at the heart of all this is called MSCNN-LSTM. Yeah, I know it's a mouthful, but the idea behind it is actually pretty brilliant. It's a hybrid AI model. It mashes together two different kinds of neural networks, one that's great at spotting patterns in space, and another that's amazing at understanding how things change over time. Together, they can spot faults with incredible accuracy, even when they're working with fuzzy, low-quality data. So how does this AI actually pull it off? Right? How does it manage to hear a fault that all that other expensive equipment would miss? Well, it all comes down to how it sees patterns as they unfold over time. You can actually break the whole thing down into four pretty simple steps. First, a cheap IoT sensor just gathers some low-resolution vibration data. Then, the first part of the AI, the MSCNN, sifts through all that noise to find any important patterns. After that, its partner, the LSTM, looks at how those patterns are changing over time. And finally, by combining both of those analyses, it makes a super precise diagnosis. Here's a really easy way to think about it. The first part, the MSCN, is like a detective who gets handed a blurry, low-resolution photo from a crime scene. Their special talent is being able to pick out the crucial clues and patterns that everybody else would just miss in the noise. And then, its partner shows up, the LSTM. This detective's gift is an incredible memory. It takes all the clues the first detective found and puts them in order, analyzing the sequence of events to understand the full story. And by doing that, they solve the case. They're an unbeatable team.
Now, this is way more than just a clever piece of code. This is a technology that has a massive ripple effect in the real world. I mean, the benefits here could completely change the economics of industrial maintenance as we know it.
I mean, just look at the highlights from the research paper. We're talking about cost-effective, real-time monitoring. We're getting high accuracy, but with low-resolution data. This directly leads to reduced hardware and maintenance costs. And maybe most important of all, catching these faults early just makes our machines so much more reliable.
So what this all adds up to is pretty huge. This technology is breaking down those old barriers of cost and complexity. It's basically making predictive maintenance available to everyone, allowing us to put this life-saving tech on way more machines in way more places, making our entire industrial world more efficient and resilient. So that brings us to the future. What does a world with this kind of technology actually look like? Well, the implications go way beyond just fixing motors before they break. You know, this story isn't really just about bearings. It's a preview of a future where our most important infrastructure is actually intelligent. Just imagine a world where everything from wind turbines to city water pumps can report on their own health in real time. That creates a system that's not only way more efficient, but also a whole lot more sustainable. Which leaves us with one last, really fascinating question to think about. This ability to pull incredibly valuable insights from low-quality data, it's like a new superpower. So if today's AI can hear the faintest whisper of a tiny bearing about to fail, what other critical, invisible problems are we about to solve next?